Welcome to the session on innovative research approaches. It's in two parts. They're not particularly well connected, other than we're both talking about innovative research approaches. Tom Carl here is going to go second. I'm going to go first because that's the way it's in the program. And we have plenty of time. When I present, I'm quite happy for people to interrupt me and take questions as I go along, rather than go through to the end. Secondly, this is something which is developing where there's a lot of things unknown. So anybody has any comments, ideas, or critiques about this, they'll be very welcome, because I think everybody is trying to learn about the areas I'm going to talk about. So, myself, I'm Chris Voss. I'm a professor at Warwick Business School. I have a 20% contract at Warwick Business School. I'm an emeritus professor at London Business School, and I've been around forever. So I know, that's why I know quite a lot of you. So thank you for coming. The motivation to do this goes back to the article I published on case research in 2002. It proved to be a very popular, widely cited, 300 sites, nearly 400 in the past year, according to Google Scholar or whoever. So it's obviously a well-used paper. But it's 15 years ago since it's published, probably 18, 19 years since it was written. So I'm beginning to wonder, is it all still valid? If people are using a methodology paper I wrote 18 years ago, should I think about updating it? So this is really driven by the need to think about updating. So with my colleagues at Warwick, we thought about what areas should we be thinking about updating this work to help researchers. We thought about design science, which I'm going to focus primarily on today. We thought that one thing that's happened since we started, people are starting to use abductive research approaches. Now, if I have time at the end, I'll say a little bit about abductive research approaches. We had very little in this paper about how to write a good paper. Most times when people come to ask me about my research paper, they don't say, what about the methodology, because I've written a very good paper. It's very clear. What you haven't said is, how do I write the paper? And that is also a big issue for a lot of people, unlike some quant papers where there's nice, this is the way you do it, boom, 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 boom. It is less clear. And the fourth area was, we just said operations management. We didn't really explicitly look at supply chains. We want to bring in supply chain. So this is an agenda I have. I'm only going to focus today primarily on the first one and possibly the second one. So, design science. How many people have heard of design science, per se? Well, quite a few. That's great, in which case, lots of comments. How many people are doing research with design science approaches? Oh, one, great. Well, you can help me this one. I'm pleased to hear this. Have you had it published yet? Yes. You have? Great. Oh, in which case, come up the front. Okay. Design science, a background. The quote I like on this is, explaining long lead times is different from taking action to reduce them. Most of us in academia spend our time researching, so why are lead times long? What are the problems causing lead times wrong? You know, what can we learn about this? What can we tell companies? We're into explanatory research. It's been argued into as well as description-driven research, we need prescription-driven research. We need research which actually helps people to manage. We need to design things. So design science comes from the idea of designing artifacts from engineering, leading not to product solution recipes, but to field testing technological rules, be used as exemplars, develop knowledge for design and realization of artifacts or principles to be used for the improvement of existing entities. That's a rather long term from Van Aken, who was the original writer on this in operations. Why is there increasing attention to design science? Firstly, the impact outside academia is becoming important. All of us are judged on an impact in academia. They look at our citations, they look at the journal we publish in, but increasingly the people who fund business education, people who fund business research want impact in industry. They want impact in social impact. They want environmental impact. Therefore, impact is becoming important. They want relevance. Any business school here who's part of ASCSB, one of the things they'll judge you on is relevance. So they want research that's relevant. So one of the reasons why people are beginning to look at design science, will it help us to produce relevant research? And our current approach is based on knowledge transfer sufficient. For example, every empirical paper I know has an implication for practice in it. Somewhere near the back end. The question, does that ever lead to practice? Is it ever read by a practitioner? Is it ever translated into practice? I would guess no. Thank you very much for that one. The answer is it's probably not the best way. They may be great papers, great knowledge, but it takes something more to get something to practice. The second is there is a risk of lost in translation when you try taking academic work and transferring it to practice. Some of it gets lost. It's not an easy thing to do. The science scientist tries to go one step further. It sees knowledge transfer in terms of action, not just as transferring knowledge, but actually producing things which are actionable. So that's basically one of the reasons behind people trying to do it. Again, why is there why the attention to science research and OM in the supply chain? One of the things that was driven things was the Journal of Operations Management formed the design science department and published a paper on doing design science, and that has kind of led to a whole number of people trying to do this. I'm one of them. I've got a revise and resubmit at the moment on a design science paper. But like all the ones that I'm quite sure, they're ones where the design science methodology has been added ex post rather than ex ante. So we say, oh, I've done this, so I could fit. It looks like design science. At the moment, we don't know a lot about design science, but this has created a lot of attention to design science. In the US, there's some pressure to move away from the ivory tower. A lot of people see a lot of research as an ivory tower where it's done in the business school, stays in the what's done in the business school stays in the business school and is read by other business schools. And there is a attention to do that. In Europe, there's a lot of applied research done in Europe, particularly in the Scandinavian countries. Then the people doing that have a completely reverse problem. We do applied research, we're pressured to work with companies, but how do we get this stuff published in a good journal? Because it's really hard to do things. There is a reverse problem in Europe. I can't speak for Australia, so I don't really know Australia, so I'll just stick to America, North America and Europe. And DSR potentially provides a blueprint for doing rigorous applied research and provides a potential route for publication in good journals for such research, for applied research. So one of the attractions, particularly in Europe, is that it provides the potential for getting rigorous publications in good journals for applied research that people like doing. So that's one of the attractions why it's becoming certainly quite a lot of investment in Europe. So a little bit of background. Design scientists are not content with merely explaining about predicting, but indeed shaping the phenomenon of interest. And in DSR, the research is interested in developing a means to an end, an artifact to solve a problem. The word artifact is used quite widely in design science, but it could be design principles. It's a very broad term. In some areas, I'll come back to this later on. In IS, where design science is much bigger than in operations management, artifacts are much clearer. An artifact is a program of some sort, or an app or something. In operations management, it's still not clear what an artifact is. In design science, Journal of Operations Management, I like to see it as developing generic designs for effective action. That's quite a nice phrase. I quite like it as a phrase. Unlike action research or clinical research, it is developing solutions that be used by practitioners in multiple settings. How many people here do action research? Or quite a few. There's a lot of questions, and maybe you can come back to this at the end. As to what is the difference between design science and action research? And one of the things is that design science should explicitly consider how do I apply this in multiple settings and not just in the setting within the action research is done, or the action research will develop theory. So it is about that is at least the theory behind design science. Generic design propositions that can be deployed in the same or related context. In other words, even when you develop a solution or an artifact or a design, it is for application, it's some sort of boundary. So knowing the boundaries is not for everybody, but there is a boundary within which this can be applied. And DSR must have a substantial evaluation element, and in particular for DSR, how strong is the evidence that the design would deliver the design results. This is what you do anyway with the engineering design, architectural design. You make sure it works. So that's often called the pragmatic validity. So does this produce something that works? That, in other words, you've produced it and it's led to the desired solution, which is the solving of the problem that you've got. And in what way does it address a significant field problem to exploit a promising opportunity? So design science is about trying to find problems, often quote wicked problems, or field problems, and develop that. So you need evidence about the practical relevance. This is something which is practically relevant and not just an intellectually interesting thing to do. And you need evidence that it would design and deliver the design results. And that I'll come back to evidence later on, because in my mind it's the evidence area where in operations at least the design science is less developed for various reasons. And justification concerns not truth but effectiveness. In other words, it works. Is a kind of at the end of the day, if you're designing a motor car, if you're designing something, you want to make sure it works against what you want to do. So that leads on to a key element of design science research, which may differentiate it partly from action research and from clinical research, is generalization. A generic design is design that can be transferred within a certain application domain to contexts other than the ones in which it is to be made and tested without losing its basic effectiveness. So that's the essence, one of the essences of design science. It is something which is transferable or generalizable. The literature is generalizable, but people do this say transferability is probably a better word. And for OM systems with significant social components, design generalization requires serious effort, and therefore they're often context dependent, and therefore good design science research should be able to explore the nature of the context and how the context may impact the application of the solution that you're developing. So that is what we see here. And the pragmatic validity refers to whether it will work after contextualization and implementation. One of the problems anybody setting out to design science research finds is there is no established consensus of what is the process for design science research. I don't know if you had that problem. You did.
Yeah, but in this regard, actually, the abductive mode of reasoning, I found it pretty interesting as a match with design science. Because you are producing something that does not exist in nature. That's the definition of artifact, at least according to Simon.
Yeah. So it is very similar. If I get time, I'll come back to the end. But the process of doing it, and although there is much commonality, a lot of people have written about this, have started publishing, but there's no clear process, which actually makes it difficult for us in operations management to work out exactly what to do to make it work. I put forward what I call the classic view, and the classic view was the one put forward by Van Aken. He states it's initiated by the researchers interested in developing technological rules for a particular type of managerial issue. In other words, you have an issue or a problem, and you set out to try and solve that problem, either with an artifact, either with rules or a program or something. Each individual case is provided or solving the local problem in close collaboration with the local people. In other words, it's something you don't do in your lab. You work with the company, your organization, in solving this problem and coming up to a solution for this problem. And following a reflective cycle, because invariably you come up with a first round design, it doesn't quite work, and you reflect and you improve it until you get it. You develop knowledge that can be transferred to similar contexts on the basis of reflection and cross-case analysis. He argues you probably do alpha testing, analysis of the effectiveness of the rule or the program or the artifact in the original context, and having got that right, then you try it elsewhere through beta testing, and the beta testing translate the rules to other contexts, having third parties use it, assess its effectiveness, and make the final improvements. And that's what I would call the classic approach as written by Van Aken in 2004. I might add that Van Aken, who's proposed this, is not an operations management person, has never been near an operations, so it's slightly abstract. So in operations, people trying to do this, there's a lot of people. So a typical example, in 2016, Van Aken proposed 2 iterative stages, exploratory and design, and then testing the designs. That's very similar, slightly narrow. May had 5 stages: problem identification, solution design, prototype development, evaluation experimental, evaluation observational. Holstrom saw 4 complementary phases: solution incubation, solution refinement, explanation, substantial theory. And that's the first time anybody in writing about this is actually, we're also developing theory, because one of the critiques of the early writing about design science is it has not been very explicit about developing theory forward. Well, you apply theory, but actually you should be developing theory forward. Yes?
Actually, there's a paper in DSS 1995 by March and Smith,
Yeah.
and as some of the possible artifacts of design science that they sort of mentioned were methods and instantiations, even though they are IS people pretty much in DSS. They were thinking about methods that we create as the potential.
That's right. Yeah. Yeah, the ISS people are doing it long before operations management. I think because the artifacts are methods are much clearly defined. I agree with you fully. And this is, they got the 4 components: explains standard theory and explanations formal theory. This particular paper argues that actually design science is about having developed a solution to see what that solution tells us about theory, in the narrow defined, and then more broadly. Although it's rarity, there's a potential. Not enough people at the moment see this as there. Other ones, a number of people follow varies in what's called the CIMO logic, which you identify a problem in its context, you perform an intervention of some sort, analyze the generative mechanisms of that, which means how does the intervention produce results, and then evaluate and verify the outcomes. And that was developed independently of design science, but it seems to be a number of people use this as a design science context and sometimes mix the two together. It's called the CIMO method, and Holstrom and Al have slight variation of this. But you see quite a lot of people interested in the generative mechanisms, which is really saying, how does it explain the outcome that we get? So the process of DSR, as it's being done in operations management, has a number of common features. The first one is problem identification. Ideally, you need to find a problem, a real problem, what is often called a wicked problem, difficult problem, then to develop an artifact, a solution, design propositions. It could be quite a range of things which address this problem and will produce results. Then to test and evaluate in the original context, alpha testing, and has an iterative process. And that is common to virtually everybody doing design science, research, and operations management. What we then see is that there are also features which are not common to all usages. So there is a focus on the generative mechanisms. The argument is about how we get the results. Testing and evaluating in a broader set of cases within the domain of solution, the beta testing. Surprisingly, few papers published so far do that very well. And I'll come to reasons for that, but I think maybe that will change. But at the moment, people are not going very generic, not looking very much at transferability. Van Aken originally talked about getting saturated evidence, sufficient evidence to prove conclusively that your solution, your propositions, your whatever will transfer effectively, widely. No one's done that yet in operations management, which is the evaluating transferability. And some people, but not everybody, looks at developing theory. So we've got the kind of what I would say everybody does, and and I'll return to this, but there's quite a bit of dispute as to exactly how far you go in doing this, in doing design science well. Potentially, it's been argued it differs from the clinical action research, because action and clinical research aims to develop a solution to a particular problem identified by researchers or organizations, developing solutions that are generic or design properly which can be used in professional to address the class of problem in different contexts. It's very simple claims to go one step further. People argue over this. I'm not prepared to fight either way, and it requires evaluation of solution design in multiple contexts. And I've said here, requires a saturated evidence. So I suggest refining. There are particularly 5 processes. The first, problem identification. Next, the problem solution leading to an innovative generic design. The evaluation of the original solution, and then the testing and evaluation of the solution in different contexts. Those I think are what I would see as the generic 5 stages. Agree? Yeah, fine, very good. In the information system of ISS, there's a much longer, as just pointed out, much longer tradition of doing design science. For example, it's been argued by Henry Vidal, who's done a lot of work on this. It should be used to address wicked problems, which are ones which unstable requirements based on ill-defined organizational context, complex interactions amongst subcomponents, and we see this in supply chain a lot, so it's very similar to supply chain, and human cognitive social abilities needed to produce solutions. So this is where they see design science as being most effective. You're trying to develop address a significant and complex problem and not a simple problem. I'll come back to that later. So, for example, I won't go back into this, but here is a guideline for doing design science research in IS, designing an artifact. For those of you who've read about this, I discovered the spelling of artifact is different in America than in Europe. So that's American spelling. In Europe, we say artifact with an E, although it doesn't matter at all. It struck me. Problem relevance, evaluating design, getting research contribution, making it rigorous, design of the search process, and then communicating on the research. So that's kind of guidelines, and there are many of those. There's more years in operations management in doing this, and they're rather further down the line at defining how and what we should be doing in design science research, because it is easier to do and faster to do in there. The classic model requires evaluation of the initial solution, design proposition in terms of effectiveness, transferability at two levels, initially and the broader context. At the moment, there's no clear guidelines as to for evaluation OM, other than you make sure it works, you make sure it's transferable. There's no, at the moment, we are short of clear guidelines. If we're going to do this more rigorously in operations management, I think we need to develop these. And again, many OM papers do not, at the moment, evaluate broadly anyway. So it's a problem. IS, as you might imagine, had developed guidelines and alternative methods of evaluation. Just to give an example, they've come up with observational, analytical, experimental testing, descriptive, lots of different methods of evaluation, which I think is fair. Evaluate is not, there is one way of evaluating. You've just got to show you can evaluate it and evaluate it well, and prove it works, pragmatic ability, and prove transferability. But I think we have something to learn from IS. I looked at it in case research. Typical case in design science is multiple cases. In best practice, uncovering technical rules already used in practice. In best practice research, which I've done a lot of, it's about uncovering technological rules already used in practice. In DSR, it's developing those rules and testing them in the field, and that could be in a single case, or it could be all sorts of means. So, example, initial selective cases of theoretical sampling for solution development. Companies that operate in the same problem setting, which exemplify contrasting characteristics, evaluation through cross-case analysis, and the second round of cases developed through theoretical sampling for evaluation of transferability, generalizability, so on. So in other words, in case research, it can be used very much, but you don't have to use case research, but it is an area where case research is used a lot. An interesting example here, just to give you a flow chart. This is by the latest published paper about design science research. They tried to take a case study research and design science approach to the CMO logic, study the problem in its context, case research, design an intervention, observe, evaluate how it worked in the process, then look at the general mechanism, evaluating the outcome of the intervention, and then revisit to see how the solution has evolved over time, and the iterative process to develop what they say are design propositions that guide practitioners to adjust intervention to context. I might add that this particular paper did not test it in a wider context. They just developed it and said, we think it's transferable. They developed it in two contexts. I'll give you an example, one example of how people are trying to do this in operations management and supply chain management. Here's another example, which I won't go through in detail, but here's our work at the moment, where we're doing some design science approach, where we try to actually map, basically from mapping exercises, what are the things which characterize the contract, the context, witness curse, low relationship quality, co-production, complex operational service network, to what were the mechanisms triggered by this to try to solve this, which are effectively collaborative KPIs and aligned incentives, all the various elements, and then map from this as to how these affected the outcomes, transparency, operational performance, trust, and higher relations to quality. So this is just part of what we're doing, work in process, trying to say what are the generative mechanisms, the context, the mechanisms, the outcomes, in the context, the intervention, the mechanisms behind that intervention, and the outcomes. So we have a map to try to explain why the solution we developed, what the nature of the problem was, what the solution was, what was the nature of that solution, and why that solution in turn led to the outcomes. So that's what we're trying to do there. You may never see that again because it may well get rejected by the Journal of Operations Management, but we are trying to see if we can do it. Yes.
Very good question on the previous slide.
Please do. Yes.
How can you actually come up with? I think, yeah, this one. So one of the stages in this framework is getting some notion of generative mechanisms, but it is preceded by the intervention. So my question is, how can you come up with an actual intervention without having at least a hypothesis of the generated mechanisms that would actually trigger the change?
That probably is in there, I think, yeah.
Right.
I probably think it's implied that you're going to, it's an iterative process, so this doesn't show the iterative process. You have your initial view, what mechanisms might generate this, and then you test it, see the change, understand the mechanism, what's worked, then it goes iterative at this level and iterative at this level.
Like this redescription stage of critical realism, right? You go
Yeah.
in circles.
Absolutely. In fact, you've actually, I'll mention maybe in one of my slides, it's very similar to critical realism, very, very similar. And anybody who works on critical realism will see there's a big parallels to the critical realism approach. Okay, how are we doing for time? 5 minutes, okay, yeah, just about get there. 10 minutes, I'll do 10 minutes, yeah. Okay. So JOM, Journal of Operations Management, has set forward what they look for in a good paper. One which describes sufficient detail that practitioners can use it as a model for designing. That's the principle. They then set criteria for a good DSR paper, provides new and valid answers, a generic design, solid analyses of the problem, saturated body of evidence of pragmatic validity, sheds insights on the material and social mechanisms producing these outcomes, and gives ample recognition to design and design approaches, etc. So a set of things which is very much what I've said. I might also add that no design science paper I've seen in operations management, maybe apart from your own, has actually covered all of these. So it's pretty demanding, and it'll be interesting to see what actually happens in reality. And this leads me to our final slides. Is what are the issues and questions in design science research? In other words, it has been proposed a lot. It is new to operations management. People are trying it, but in trying to do it myself and talking to people, there are a lot of unanswered issues still in there. Firstly, there is no consensus or accumulated research experience in DSR in operations or supply chain in particular its process. In other words, people are doing it somewhat differently, and aren't this, so there's no clear, at the moment, problem to it. Maybe in 2 years' time, when the first round of papers in JOM get published, we'll get a much clearer view on that and all the value and how you evaluate. Secondly, the time it takes to develop and test a solution and then test it again more broadly. I can see you smiling there. One of the things about if you're doing proper design science research, which nobody seems to be doing very much so far, you develop the initial solution, then you test it again in a much broader context, which in operations and supply chain management can take a lot of time. Would you advise a PhD student to do this? I'm not sure, because it takes so much time. I have a colleague, a Finnish colleague, who started his PhD about to do design science research, and then said, maybe he was actually a student of Holstrom, who did a lot of this work, and decided he wouldn't have time to do it properly because he wouldn't have time to do the broader mechanism. The need for substantive evidence of the generalizability. At the moment, no one's doing this very well, and the question is, how easy or well can we do this in operations management? I'm not sure about this yet. I'd like to see some evidence. We're trying to do this. We've got, I think in my research, we've got 2 companies, apart from the original one, but it's actually, maybe people setting out to do this in advance, ex ante, will set this out much better than those trying to do it ex post, as people are trying to do it right now. What is a suitable problem, or a wicked problem? How major a problem should it be? One of the questions that always goes to my mind, is it easy do you just look at simplistic things where you just produce a checklist at the end, and that's your solution? Or should it be a really significant problem we're trying to solve? And that is an unanswered question. How significant a problem are we going to end up with using design science for? Because in theory it should be for significant problems. And when and where should we not set out to use design science if you're doing pragmatic research? And then what is an artifact? Is it in IS it's clear, such as an app or a program, or you know, in operations management, supply chain, it's not so clear. Is it a checklist, a roadmap for change, benchmarking? All of these in theory could be. I don't think they really they don't go far enough. You've actually got to do something a little bit more substantial, maybe. It's a good question. As to what we need some views on what makes an artifact, what makes a significant set of design propositions in OM, and we need some evidence of that. How specific and/or generic should design propositions be? When you do it in a particular company, if you're developing a generic design, it should have application in a wider set of uses within that narrow context. And the question is how should that be? It's also at the moment not entirely clear the real difference between clinical research or action research. Again, welcome your views on that, for people doing that. And if we already have publishable research, do we need the extra effort to get the design science in? One of the dilemmas is the first set of design science research actually may be sufficient to get a good paper, so why bother to go further? Although the idea is it will enable you to do much more practical research. So my approach to this problem, first of all, a DSR add-on to existing research was proposed by JOM. In other words, you've done some existing research, let's publish an add-on which says, here's how we tested existing research in a broader context, which I would say is quite a good way of doing things. Explicitly limited broader testing, we don't do very much. Well, like Kaipo et al., the latest one, is this approach sustainable in the long run? And there seems to be a spectrum from what I would call full DSR to DSR light. So if you just take this diagram, got problem implementation, solution, innovative generic design, evaluation of original solution, evaluating, testing in different contexts. Clinical research goes down as evaluating a solution. DSR light goes down to evaluating solution and transferability, but you don't actually transfer it, you just evaluate transferability. One step further says you go down with partial test of transferability, which you see, I think, in the Kaipo et al. And full DSR says you full test and evaluation, you go through all these, and you do a full test and evaluation of transferability. But you also have what I call the add-on. You've got existing research and not conducted DSR, but then you've got down to here, then you can test and evaluate that in a wider area. So I think we've got a lot of choices. Most of what is published at the moment is there, or even here or here. So far, in terms of, as Van Aken or Journal of Operations and Management states, no one's really done the full Monty, the whole lot. So it may be, as the pragmatic validity will increase as we do it more. So, summary so far: it's about producing generic designs for effective action. Has two basic processes: designing and evaluation of OM, supply chain artifact, develop a problem. It's an iterative process, and its outcome can be judged on pragmatic validity and transferability. Have I got 2 minutes to look at? Yeah. I'll just answer one of the questions you brought up earlier on, which is, first of all, is a copy menu. At the moment. Most of us, when we do our empirical research, either use an inductive way where we take an observation, there's no theoretical explanation. We develop propositions from our data, which is an inductive way of doing things. Or we do a deductive, where we have a theory, we develop hypotheses, we then go and observe empirically, case or survey, and then we look at pattern matching, and we get generalization of theory. I think you were giving some hypotheses this morning, Eve, I think. Yeah, that was I would call deductive. Then there is abductive, where the observation is incongruent with existing theory, and therefore you try and put forward emerging theory. You then try and test that emerging theory in the field and come up with new propositions, new framework, and extension to theory. That's the abductive, which people are beginning to use, saying, okay, we've got theory, but actually what we see doesn't match existing theory. How can we test this to see if that theory is right or improve the theory? And then with design science research, we start off with a problem where there is a theory available, and then therefore we try to see if we can apply that theory to solving this problem, evaluate the original context, refine and go around, refine and go around and evaluate. And then once we've solved it in the initial context, we evaluate in a broader context, we then feed that and see if we can extend the theory based on what we've observed. That's how I see, and as you might rightly point out, it's there is quite a similarity to the deductive approach. So, to finally summarize, it's now a topic that many OM and supply chain scholars are thinking about. In many ways, it reflects how we research in Europe, particularly Northern Europe. It potentially provides a pathway for publishing applied research in quality journals, but it's potentially very demanding and time-consuming. And at the moment, there is no single model how to do it well. So watch this space. I'm trying hard to see if I can do it. Other people are trying hard, and hopefully we will come up with something. Maybe we should read your paper as well. What's your paper on?
It's actually in the IS area, so that explains.
Oh, explains a lot. It's in the IS area. Yes, exactly. Yes, very good. So that's basically what I thought to do today is take something which very few people doing, very people know about. Let's try and get it on the table and see what we do know and what we don't know about the application of design science. Okay, any comments, questions before we